The Pumpkin Pie Bakery Part 2. So in class, we'll talk about the pumpkin pie problem that we looked at yesterday, and we're going to add more to it. Janelle and Hector work at the Pumpkin Pie Bakery as pie makers. Janelle can make 10 pies in 2 hours. Let's highlight that. And Hector can make 9 pies in 3 hours. Assume these rates are constant. How much profit do they bring in the bakery? Or do they bring the bakery? Okay, so I think it'd be best to figure out like how many pies per hour. So let's look at Janelle. She can make 10 pies in 2 hours, which is 5 pies in 1 hour. Okay, what about Hector? Hector can make 9 pies in 3 hours, which is 3 pies per hour. Okay, so then together in T hours, it's 8 pies every hour, so it'd be 8T, where T is the number of hours. Recall that the amount of profit the bakery earns each day depends on the number of pies made N. This profit can be found using that function we looked at yesterday. So it was that overhead cost and then that $15.50 per pie. If Janelle and Hector made 20 pies, how much will the profit will the bakery earn? So again, if we look back to yesterday, it was right here. So it was that $19 per pie minus the cost, and that is how we came up with the profit function. All right, so for 20, the profit for 20, we would just plug in 20 pies would be 15.5 times 20 minus 85. Okay, so that's 225 pies per hour. Whoops. Actually, not pies per hour, is it? It would be profit. Profit for 20 pies. There it is. Okay, it says last Saturday, Janelle and Hector worked for 5 hours. How many pies could they have made during that shift? All right, so number of pies per shift was 8 pies per hour. So 8 times 5 would be 40 pies. What would the profit be? Well, we know that in 5 hours they make 40 pies, but the profit, so we plug into this equation, the profit for 40 pies would be 15.5 times 40 minus 85, and that would be a profit of $535. The manager of the bakery is trying to decide how many hours to schedule Janelle and Hector to work based on a desired amount of profit. Complete the table below. All right, so let's say T is the number of hours worked. The number of pies would be 8 times T. I'll just call this the number of pies. But then the profit would be the number of pies, and they would plug into 15.5 times N of T minus the 85. All right, so let's start with numbers. I think it makes more sense. So for 3 hours worked, it's 8. Put the pencil up here. 8 pies per hour, 3 hours worked, which would be 24 pies. And then if we plug in the profit of 24 pies would be 15.5 times 24 minus 85, which would be $287 profit. Okay, what about for 6.5 hours? So it would be 8 times 6.5, which is 52 pies, but the profit of 52 pies would be 15.5 times 52 minus 85. I can't really squeeze it in there, but it's a profit of $721. And then the last one, what if they worked for 8.25 hours? That would be a total of 66 pies, and the profit off 66 would be 15.5 times 66 minus 85, which would be, $938. It says, write an expression the manager can use for determining the amount of profit based on the number of hours that Janelle and Hector work. All right, so the profit would be 15.5 times the number of pies, and it was 8 pies per hour, minus 85. So basically, this is the profit if you know the number of pies made in n hours. All right, so this is called a composition of functions. When you plug one function, 8t, we use that answer to plug into the profit equation. So you find one answer and use it to find your next answer. It says, one day the manager forgot to write down Janelle and Hector's hours. She does know that they made $411 in profit on that day. Can you figure out how many hours she worked? Well, let's try to solve it backwards. We have $411 equals 15.5 times 8t minus 85. We can solve this algebraically. We can add, 85 to each side. And that would give us 496 equals, we can multiply 15.5 times 8, 124t. Divide each side by 124. All right, so t would be 4. 4 hours would give that profit. All right, so quick notes. What we have done today is called a composition of functions. I'm going to erase this so we have a little bit more room here. A composition of functions is when you use one answer to find the next answer. So we needed to find the number of pies made, and then we could plug that in to find the profit. So composition of functions. All right, so what you do is you're going to use the answer of the first function to find the answer to the second function. Again, the example was we found the number of pies, and then we used that answer to find the profit. So function notation, let's say we had two functions, f of x and g of x. When you do the composition of functions, I might ask you to find f of g of x, which just means find the answer to g of x and plug it in. Or I might ask you to find g of f of x, which means you find the answer for the first function and you plug it into the second function. Okay, so again, we're going to take a look at how do you do this? How do you find a composition of functions? So let's try it. Let's plug one function, the answer of one, into the other. So let's say the first function is 3x squared. The second one, wx, is 4x plus 1. And our last function, f of x, is this table of values. Can we find v of w of 3? All right, so let's find, you start with the inside function w of 3, which is this one. All right, so the first step is we'll do w of 3 equals, and we're going to plug in. Everywhere we see the x, we'll plug in. So 4 times, instead of x, 3 plus 1. So w of 3 equals 12 plus 1, or 13. All right, now we're going to take that 13 and we're going to plug it in for this function right here. So v of 13 equals, and here's the v function, 3x squared. So we'll do 3 times 13 squared. So 13 squared is 169. 169 times 3 is 507. So we'll say v of w of 3 equals 507. So it's just taking one. Here's our first step, finding the answer, plugging that into the second function, and finding the final answer. right, let's do the next one, v of f of 4. All right, so first you find f of 4. That's this table. So when the input is 4, what's the output? It's 1. So f of 4 equals 1. Now we plug that into the v function. So v of 1, let's look at the v. It's 3x squared. So we'll do equals 3, and instead of x, we'll plug in a 1, and we'll square it. So 1 squared is 1 times 3 is 3. So we would say v of f of 4 equals 3. So you take one function and you plug it into the second function to get your answer. All right, let's try the next one. V of w of 1. Okay, so w of 1, start with the w function, which is here. All right, let's plug in. W of 1 equals 4 times 1 plus 1. So w of 1 equals 4 times 1 is 4 plus 1 is 5. All right, so now right here we're going to plug the 5 in and find f of 5. So the f function is the table. So when the input is 5, the output is 0. So the final answer is 0, and we would say f of w of 1 equals 0. Okay, let's try another one with numbers. V of 7, w of v of 7. So start with v of 7 first. So here's the function. V of 7 equals 3 times 7 squared. All right, 7 squared is 49. 49 times 3 equals 147. Okay, so now we do w of 147, w of 147 would be this function, so 4x plus 1. Okay, so let's plug in. So it'd be 4 times 147, and then it's plus 1. And then our final answer is, it'll be pretty big. 4 times 147, 588 plus 1. So it's going to be 589. So the final answer, we would say w of v of 7 equals 589. Okay, what about when we plug a function into a function? So if we have v of w of x, I'm going to kind of erase up here. No, I won't. All right, v of w of x means we start with the w of x function, and we're going to plug it in for this x right here. So I'm just going to rewrite the whole thing. So we would have 3. Instead of the x, we're going to plug in what wx equals, 4x plus 1. So 3 times 4x plus 1, and then it was squared. Okay. So this is what it would look like, v of w of x. And then here, I mean, we haven't learned how to multiply out this right here, so I'll just leave it like this. Okay, let's try the other way. Let's do v of w of x. So this time we start with w of x, the inside function. W of x, let's erase this. And we're going to plug this into the x right here for the w function. So it'll be 4, and we're going to plug in 3x squared, and then the rest of the function is a plus 1. In this one we can simplify further, so this will be 12x squared plus 1. So when you plug a function into a function, you will get an equation answer. When you plug a number into a function, you'll get a number answer. And the last two, what if it gives you the output? This is the output. Can you find the input? So this is the output. What's the input? All right, so it's w of x. Let's look for that equation. It is 4x plus 1. So this is saying 4x plus 1 equals 29. Can you go ahead and find that answer? So then you would just solve. So if it gives you the output, you plug it in and you find the input by solving. We get 4x equals 28, divide by 4. So the input is 7. So we would say w of 7 equals 29, or the input is 7. How about this one? When the output's 48, what's the input? And the v of x function is 3x squared. Okay. So the output is 48. We want to know what x value would be the input to get that answer. Let's solve the equation. We'll divide by 3. 48 divided by 3 is 16. So you have 16 equals x squared. We take the square root, and we get x equals 4, but also negative 4 would work as well, because if you square it, it would be positive. So there's two answers here, 4 and negative 4. All right, so we've looked at function notation. Again, if you have the input, can you find the output? Output, find the input. The assignment for this day, let's see if there is an assignment for this day. Oh, there is no assignment. So we'll go through this in class, and then you have kind of a day to get caught up on the previous work from your packet.